Okay, so this lesson is on differentiating exponentials and logs with a different base other than e. So the base could be a, we're going to call it a here, where a is just any constant. So this is the rule that we have for differentiating a to the power of x. It just ends up being log of a times a to the power of x. And we'll just go through the proof of where this rule comes from. So if we let a equal e to the power of y, then we can just change this to log form by saying, so the base here is e, so same when we go to log form, the base will be e, and it'll be log of a equals y. And we'll just check that by using the circle. E to the power of y equals a, and we've got e to the power of y equals a. So that means then that a, because we've got a equals e to the power of y, if y is log a, then that's the same as e to the power of log a. Alright, now, if we raise both sides of this equation to the power of x, then we've got a to the power of x and e log a to the power of x, and using our powers of powers, this becomes e to the power of x log a. And differentiating both sides of the equation, then, if we have d dx of a to the x, well, that's going to equal the derivative of the right-hand side of the equation. And the derivative of the right-hand side of the equation, you know that when you're differentiating exponential e to the power of anything, it's e to the power of f of x, it's f dash x, so the derivative of this is going to be log a, because remember, a is a constant, which means log a is also a constant. And then you keep the e part exactly the same. And so there's our rule. The derivative of a to the x is equal to log a times e to the power of x log a. And remember that e to the power of x log a is this, which equals a to the power of x. So we can say that that is equal to log a times a to the power of x. And there we have the rule. The derivative of a to the power of x is equal to log a times a to the power of x. Okay, now the proof for differentiating log of x base a is a lot easier, and it's dependent on the change of base rule that we covered in the last couple of videos ago. So first we are going to change, or we're going to let y equal log of x base a, and then we're going to use the change of base rule to change this into log of x over log of a. And then differentiating this, differentiating both sides of the equation, then the derivative of the left-hand side will equal the derivative of the right-hand side. So the derivative of y, which is, remember, is log of x base a, is going to equal the derivative of the right-hand side. So the derivative of the left-hand side, which equaled that, is going to equal the derivative of here. Now, you know the derivative of log x is just 1 on x, and you know that log a, well, a is a constant, which means that log a is also a constant. So you could think of this as being 1 on log a times the derivative of log x, like that. Okay, and there you have the rule. The derivative of log ax equals 1 on log a times 1 on x. This rule now to some examples. So differentiating 3 to the power of x, that's going to be log of 3 times 3 to the power of x. Differentiating 10 to the power of x is going to be log of 10 times 10 to the power of x. Differentiating log of x base 10 is going to equal 1 on log of 10 times 1 on x. And differentiating log of x base 2 is going to equal 1 on log of 2. So notice we've got the natural log here as well, times by 1 on x. Done.